So CD has a diameter of 12 centimeters. And we're told that the angular speed is 20 radians per second. So we're supposed to calculate the linear speed in meters per second. So we want to know meters per second that this thing is doing. Okay, so this is our target units for the end. We're given 12 centimeters and we're given 20 radians per 1 second. Okay, so we got seconds in the denominator. That's nice. We just need meters in the top. And so radians are a measurement of the circumference of the unit circle. Okay, so the unit circle just means a circle with a radius of 1. And so pi is halfway around the circle because the circumference of a circle is 2 times pi times r. So 2 times pi would be 2 pi. So that's the whole circumference of the unit circle. So 1 pi would be halfway around. So we've got 20 radians. That's not in terms of pi, so it's more difficult to interpret where that ends up. But we can use this fact that 2 pi radians equals 1 revolution. Because if we can convert radians to the number of revolutions around the circle, then we can convert revolutions to a linear distance to talking about how long around the unit circle we've gone, and then we can convert that to meters per second. So let's use this conversion factor. That 1 revolution is 2 pi radians. So I'm going to multiply this by 1 revolution over 2 pi radians. Okay. So that makes the radians units cancel out. It gets us closer to having meters in the top. So that means I have 20 times 1 is 20 revolutions for every 2 pi seconds. And we'll take care of those units. We'll take care of those ugly numbers at the end. We're focusing on the units. We got seconds on the bottom. And now, how long is 1 revolution around the circle? That's where we can use the circumference formula. The entire circle is 2 pi r. That's the circumference around a circle. Okay? We're not dealing with the circumference of the, We're not dealing with the unit circle anymore. We're dealing with a circle that has a radius of 6, right? It's halfway, of half of the diameter. So we got 12 pi centimeters is the entire way around the circle. So 12 pi centimeters is 1 revolution around the circle. So that's how we're going to get rid of that revolution units in the top. We'll multiply by that other conversion factor. That we've got 12 pi centimeters for 1 revolution. So the units of revolution cancel out. So we got 20 times 12. That makes 240 pi centimeters. Over, oh, actually here the pi units are going to cancel, right? Cross cancel these pi units. That makes it a little easier. So it's 240 centimeters over 2 seconds. So we just need centimeters to be meters. There's 100 centimeters for every 1 meter. So that can make the centimeter units cross cancel. So we've got 240 meters for 2 times 100 makes 200 seconds. Or if we simplify, 240 divided by 200 is 2.4 meters per second. So that's the linear speed. Okay. Whoops, I'm not sure what I typed in the video, but this should be 240 divided by 200. So that's not 2.4. 240 divided by 200 is 1.2 meters per second.